In this video, the learner will use the properties of a kite to solve problems. First, let's talk about the properties of a kite. Its definition is a quadrilateral with two pairs of adjacent congruent sides. Remember, the word adjacent means next to, so you might want to make a note of that. Okay, we have a kite here. Our first property is two pair of adjacent congruent sides. So the two sides here are congruent, they're the ones next to each other. And then we have another pair of congruent sides that are next to each other here. The next property is that the diagonals are perpendicular. So when we connect opposite vertices, we get these diagonals, and they actually always make a right angle. The next few properties have to do with the angle pairs that we see. So we have to understand a couple of terms first. We have what are called vertex angles and non-vertex angles when we talk about kites. Vertex angles are going to be the angles that are between the sets of congruent sides. So here, between these two congruent sides, this is a vertex angle, and between these congruent sides, we have this vertex angle. The other two angles are the non-vertex angles. These are the angles between a set of sides that are not congruent. So we have the side here with two dashes and the side here with one dash. The angle between those two sides is a non-vertex angle. Then the opposite angle from that is also a non-vertex angle. It is between two non-congruent sides. Now that we know what vertex and non-vertex angles are, the next property of kites is that the non-vertex angles will always be congruent. So these two non-vertex angles are always congruent to one another. The next property, the diagonal between the non-vertex angles is bisected by the other diagonal. So the diagonal between the non-vertex angles is bisected by that other diagonal here. The last property of a kite is that the vertex angles, these two angles here, are bisected by the diagonal that goes through those. So this dotted line here bisects this vertex angle to form two congruent angles here. This diagonal also bisects this vertex angle down here and creates those two congruent angles. Now we're going to use the properties of kites to solve some problems. For this example, we're given quadrilateral RSTU, and we notice here that SR is congruent to RU and ST is congruent to UT. We also see that those congruent pieces are adjacent to one another. Therefore, we can conclude that this quadrilateral RSTU is a kite. So we know we can use the properties of kites to solve for the measure of angle T and the measure of angle U. If we know the measure of angle R is 140 and the measure of angle S is 70. Because we know this is a kite, we know that angle S and angle U are the vertex angles of this kite and will therefore be congruent. So angle S and angle U will have the same measure, which means the measure of angle U is 70 degrees. Now we have 3 out of the 4 angles of our quadrilateral. We also know that the angle sum of a quadrilateral is 360 degrees. Therefore, we can add up all 4 angles to be equal to 360, add up the ones we know and we get 280, and subtract that from both sides and we get 80. Therefore, the measure of angle T has to be 80 degrees. And I have an example down here that I want you guys to try. Find the measure of angle F and the measure of angle H. Notice you're given 128 degrees for angle G and 72 degrees for angle J. We're going to use the properties of kites to solve this problem. Find the perimeter of kite WXYZ. Notice that we are given some measures here. PW is 6, xp is 8, pz is 8, and py is 24. Well, because we know that this is a kite, we know that the diagonals are perpendicular to one another. That creates 4 right triangles in this kite. Therefore, because I have 2 sides of each of these right triangles, I can use Pythagorean theorem to solve for each one of the side lengths of the kite, and then add them all up to find the perimeter. So first, I'm going to use PZ and PY in Pythagorean theorem. So PZ squared plus PY squared is going to equal ZY squared. So PZ is 8, PY is 24, so plug those in. 8 squared is 64, 24 squared is 576. Add those together and you get 640. Then we square root both sides and simplify to get 8 square root 10. So we now know that ZY is 8 square roots of 10. Because this is a kite, we know we have consecutive sides congruent. So ZY will be congruent to XY. So XY will also be 8 square roots of 10. You notice that you could have also used Pythagorean theorem, but you would have used 8 and 24 again, so you would have wound up using the exact same measures to get 8 square roots of 10 again. Now I need to find WX and WZ. These, of course, will also be congruent measures. So I can use Pythagorean theorem using PW and PX. PW squared plus PX squared will give me WX squared. Plug in 6 and 8. 6 squared is 36 plus 8 squared, which is 64, gives me 100. When I square root both sides, that gives me WX with a measure of 10. Well, if WX has a measure of 10, then WZ has a measure of 10. Now that I have all 4 side lengths, I can then add them all up to find the perimeter. 10 plus 10 plus 8 square roots of 10 plus 8 square roots of 10 is going to give me 20 plus 16 square roots of 10. And that is as simplified as this expression will be. I want you guys to try this example. Suppose the length of segment EI is 10 feet. Find the perimeter of the kite. Notice some of the angles here inside the kite. We know that EI will be 10, and you need to find the perimeter.